Hey guys, this is 4.5, and something that you'll notice in the homework, a bunch of the dates were changed for this assignment because we were in yellow. So just kind of bear with me on looking for those date changes. So 4.5 is going to be on the 21st. A couple of changes here real quick. We're going to get rid of 30 and 31 from your assignment, but we're still going to do 3 through 13 and 21 through 26. Actually, you know what? Let me look real quick. We might make one more change. Let me look one more time and make sure I'm happy with that. Let's do 3 through 9. I'm going to change that. I guess we'll go through, we'll go 3 through 9. So let's jump back here to the homework and alter that right here. We're going to change that 13 into a 9. So 3 through 9 and 21 through 26. That's again assuming that we stay in yellow. If we come back into green, we will we'll change that assignment back and do a little bit more. So the first thing that we need to understand when we're talking about lines and graphing lines is that there are certain pieces of information that it takes to produce a graph. And so if we think about most lines, we could say that it takes 2 points to create the graph of a line. If I put a dot here and a dot here, I know that a line is going to pass through those. However, when you look at an equation, you could just pick two random x's, plug them in, and see what happens. But there's sometimes in the way that a problem is written, there are secrets in the equation that if we learn to find them, makes the problem really easy to graph. For instance, most lines, not all lines, but almost every line will cross the y-axis. And this point, wherever it crosses, it might be there, it might be down further, that's what's called the Y-intercept. Okay? And the Y-intercept is a specific point. It always crosses the y-axis. And so if we could find that Y-intercept from just looking at the equation, it's super easy to start graphing with that point. And one thing that's really special about that y-intercept, we learned a little bit about this before, was that the x is 0 on that y-intercept. So wherever that y-intercept is, we know that it's got an x value of 0, which can also help us find it fairly quickly. So if I look at an example like number 6, okay, if you put 0 in for x, 5 times 0 would be 0, and y would equal -7. So right here is my y-intercept. Now the question is, could I have found that that was the y-intercept without having to actually plug 0 in? The answer is yes. Whenever you look at these equations, there's usually an x term, and if there's an x term, if we look at the other number in the equation, that other number would be our y-intercept. So we could see, for instance, a -1 there. We can also see down here a +7. The number that doesn't use x is our y-intercept if, and only if, we have a y equals equation. Down here you could see right here we don't have a y equals equation. So on 29, I could not say that 2.5 is the y-intercept, not until I have y by itself. There might be some changes to that 2.5. So whenever we have an equation that is a y equals, the y-intercept is the number that's usually added or subtracted at the end of the equation. Sometimes we change the order like number 6, but it's this last number. We call it b in the formula, okay? This number that does not use x will be our y-intercept, okay? The other thing that we're looking for when we produce these graphs is called the slope. Because if I have one point, if I have the y-intercept, then all I have to know is how much to come up and how much to go over to create another point. And I could do this infinitely. I could keep using this slope to create more and more and more points. But if I just know the slope and one point, I can move on rise and run in order to get the specific location. Well, the slope is represented by the letter m, And in a y equals equation, it's always the number next to x. So if I look back at number 6, we would have our y-intercept at -7, and our slope would equal 5. Or 5 over 1 if you want to put a fraction together. But those two pieces of information are oftentimes just staring us in the face. Now there are times when it seems like things aren't working. Let's look at number 4. Okay, the slope is supposed to be the number next to x. But there isn't a number next to x, but there is a sign. Well, if we use a little bit of logic about what must be in front of the x, we know that -x is the same as -1x. So the number next to x would be -1, and that would be my slope. Now comes the y-intercept. I'm looking for a number that doesn't use x, that's added or subtracted to the problem. I don't see a number there. You know, over here we've got a 6, over here we've got an 8. We have numbers in these equations, but this one doesn't seem to have it. Well, if the number's missing like this, and it's just not there, the assumption is it must be 0. Which means it's going to cross right at the crosshairs of the origin. So that's the information that we're going to start with. On 3 through 8, your job is to find the y-intercept and the slope. Then, if we jump down, let's clear that out a little bit, get some blank space here. Then, if we go to where we're going to do some graphing of these problems, let's look at how the graphs are going to work. And obviously you don't need to use graphing paper because if you don't have it at home, it's not the end of the world. But you do want to make sure that you do a decent job of producing the graphs when you go through these. So we're looking at 21 through 26. Our job is to graph it using the y-intercept and the slope. So I'm going to take a really simple example like number 25. Okay? And the two things I want to get are the y-intercept and then the slope. The y-intercept is the number that's either added or subtracted but not touching x. So right here would be my y-intercept. But keep in mind, this is not just a 5. This is a -5. So on my y-axis, I'm going to go to -5. That would be down 5. 2, 3, 4, 5. This first point should always be on the vertical line. Then I have to use the slope, which equals 1 over 4. That means that I'm going to go up 1. Let me get a different color here. I'm going to go up 1. Then I've got to go to the right 4. 1, 2, 3, 4. Which would put me right about there. And then if I was really good at drawing lines, I would do a good job with this. That's not too bad. But there's my graph. So y-intercept, critical point. We've got to get that, and then we use the slope to move from there. And that's it. Ask your questions. Touch base with me. Let me know where you're getting lost, and I'll help you out the best I can. Good luck, and we'll see you in class.